here in Boston, right? Coming up on the 250th anniversary of the Tea Party.
Of the Tea Party in
right?
December, in a warm month.
In
We
December.
Get to go out there and throw tea off the boat.
3 tons of tea get thrown in the Boston Harbor by the Sons of Liberty, right?
The Sons of Liberty.
And then two years from now, we're going to celebrate America's 250th birthday.
But
right?
but before then, Jeff has some awesome stuff to present.
That's
so
right.
I'm going to give the stage to you. Round of applause for Jeff Needham, please.
Thank you. So taxation without representation. Let's stay on that for a little bit. You know, somebody asked me, a customer asked me the other day, why did you guys pick MongoDB at Travelers? So I worked with Denise at Travelers. I was part of a team that brought MongoDB into the company and fell in love with the product, started using it everywhere. A customer asked me the other day, why did you use that? And I thought of taxation without representation. You know, at the time, the group that I was in, we were frustrated. We were frustrated with Oracle. We were frustrated with relational. We were this team of agile zealots, probably not unlike the Sons of Liberty 250 years ago. But that act, just like it did for America, you know, in Travelers, started a spark, and that spark has turned into something pretty big. And I think all of us are here in this room today because we know there is a better way to work with data. We've probably all discovered it, right, you know, by now, and we probably all love that there's this thing called the document model. So what I thought we would do today is pretend like we're at work and we're inside an agile delivery team. So I've got a handful of slides. But first, what do I mean when I say essential cloud data architecture? And so when I mean data architecture, I mean 2 things. I mean your data models and your schemas, right? Your data objects. What are they? And then where are they deployed? What's the deployment architecture of those guys? And then really, what's the minimal viable product of what it takes to deliver agile features into production as part of a cloud modernization effort? So let's just answer this right away, right? The title of the presentation is How AI is Closing the Gap Between Payers and Providers. And rather than talking about the AI solutions, I'd rather talk about the obvious. AI is closing the gap between payers and providers because we are all talking about data a whole hell of a lot more than we were a year ago, 5 years ago, 10 years ago. We're talking about data every day. We're talking about vectors. We're talking about database objects. And as a data architect, it warms my heart because that's what I've done most of my career. And so I think this is how AI is closing the gap in all of our industries. We are all talking about the data objects and the databases so much more than we were. So now that that's out of the way, when I worked in Travelers, again, being agile zealots, I'll tell you kind of a story. Every agile release that we started, we would understand the features about only a week prior to the release beginning. And so there was a handful of us, about 6 of us on the architecture team. We'd get handed about 50 features, and the agile release would start the week later. And this was kind of humorously known as Hell Week for us, because we would take each one of these features, and as an architecture team, we would create these things called feature wikis. And for the folks at Travelers that can't be here today because they're all at an architecture offsite, when you watch this recording, Mike, this is for you. I hope you get a laugh out of this, but wikis were super important. And the wikis were kind of important because we would take that list of features, we'd review what they were, and we would go through and we would identify in the features, what are the architecturally significant items? What are the requirements and constraints? Because we had about 20 agile delivery teams, and we knew that as an architecture team, in order for us to promote our own selfish, opportunistic, agile agenda, an architecture agenda, we were going to steer those features in the direction that we wanted and not just let the development teams go off and build whatever they wanted. And so we would publish these detailed wikis for the team. And so our agile delivery release the next week would be, okay, delivery teams, here's your wikis, go off and now design the software, build it and test it and deploy it for us. But it always started with wikis, so I thought I would take the first half of this presentation and kind of dovetail into Francesca's presentation this morning when he talked about his Leafy Hospital demo. He's talking about how you can use Fire and MongoDB and vector search to power the healthcare side. I want to talk about some of those same data objects from the healthcare payer perspective, because for those of you that haven't heard, we're launching our Atlas for Industries program for healthcare and insurance today here in Boston. So I figured we'd pay homage to the healthcare payer perspective. All right, so we've got a business feature request. And so we know that when we walk into an Agile delivery room, we don't get the requirements analysis documents that we used to. We get like 2 sentences. And the name of the game is, as a team of developers, maybe a UX designer, and a business product owner, you get in the room and you flesh out the requirements in the room. And then you prototype, and you put that prototype in front of the business owner, and you say, is this what you wanted? So let's kind of walk through what a potential feature request would be using some of Francesca's data objects that are in his healthcare demo. So as a business owner, I'd like to automate the enrollment of members into care programs, leveraging clinical notes in order to increase utilization management scores and improve overall health. For those of you who don't work in health insurance, utilization management is a big deal, especially in the Medicare Medicaid space, because the government is going to give you, as the insurer, a monthly stipend per member per month. And if your members aren't going to get routine health exams, the government's going to audit you and say, well, if your members aren't utilizing services, I'm not going to reimburse you for those services. I'm actually going to pay you less. So is a really, really big deal in healthcare. And let's see what we can do with clinical notes and vector search to exploit the technology as a software delivery team to try and meet this goal from the business product owner. And so we know that in the feature notes that we're going to be receiving clinical notes for the first time. We don't get those right now. We're going to get those for the first time. As a health insurer in the United States, we are actually privileged to have access to those clinical notes. Yes, there's PII and PHI and data in them, but as a health insurer, you can access those clinical notes from patients. The notes are going to come to us in FHIR format. That's the Fast Healthcare Interoperability Resources format. A bunch of JSON schemas that define how you define things like providers and payers and clinical notes. We're going to have a pilot set of network providers in this initial rollout. So the feature is going to be rolled out kind of small scale for now. And we're going to have product and data science teams. These folks have already mapped out business logic for program identification and assignment. So we want to take those clinical notes and then determine, can we assign folks to healthcare programs, to wellness programs automatically? And we've got data science and product folks that have already defined what those programs are. Oh, one last thing. The current legacy member administration system is in contain mode, right? It's IMS or legacy DB2 or legacy Oracle. We don't want to touch it. We can't rewrite it right now. Big constraint in our way. So our feature architecture. So again, back into the wikis. So the things that are architecturally significant that we're going to need to prove out and clear the way here for our delivery team. The current system is in contain mode. So what we're going to do here is we are going to create a change data capture job to copy the data from our legacy Oracle database up at the top right. We're going to move that into a brand new member operational data layer. And we're going to store the member information and the clinical notes using the basis of the FHIR schema. We're going to build a new member appointment microservice that's going to allow members to view and edit their appointments, maybe receive alerts via our MyLeafy Health mobile app. And now here, it's like we're back at work, right? So I know everyone here, thank you so much, by the way, for taking a day off from work and coming here to see us. I'm going to bring you back to work, so this looks familiar, right? This is a relational schema. We've got a member at the top left, and under that member we have a bunch of child objects. We've got member address, we've got member bank account, member guardian, member languages, member contact information. And in relational, we know that repeating groups are always cast out into child objects. So a very basic data set that really only describes things I know about one thing, the member, gets broken out into potentially a dozen tables if you're doing it properly in relational. Well, we've got relational migrators, so I open Migrator and I put that same MongoDB, same target source Postgres or Oracle schema into relational migrator. I reverse engineered it. I connected our relational migrator product to it. I reverse engineered it. And on the top left, you see the same schema as on the slide before. On the bottom, you get the MongoDB version. But I haven't gone through the work yet to actually fold all those repeating groups into the MongoDB collection. So it's a one-for-one from relational to MongoDB, but I know in MongoDB I can do a lot better, right? I can fold all these little repeating groups, the member contact information, the member address information. I can fold those repeating groups into the parent MongoDB collection as nested arrays. And when you do that in Migrator, it's pretty nice because you can select your base entity of member, and then you can go up into the top right in Migrator, and you can choose to embed one of those child relational tables as an embedded array in the parent MongoDB document. And what I've gone through is I've gone through all those little child documents, and I've collapsed them into one parent MongoDB object. With Relational Migrator, I can actually move the data. I can sync, not only can I model the data out for my developers, push that into a data model, I can then move the data from the legacy database into the target MongoDB collection. So I can give the developers now and my Agile delivery team an environment in MongoDB to work with that actually contains the data from the development environment in Oracle or Postgres or MySQL. I can get these folks started developing against the target MongoDB schema in like an hour. Maybe I want a full change data capture program here if I want to really federate the data constantly in production. But this gives me the essence of what a change data capture program is going to do. It's going to take your source data, it's going to collapse it into a more elegant target MongoDB structure, and then it's going to move the data. So in our feature wiki here, now we've got a couple things. Now we've got our member collection in MongoDB on the top left there. And you can see what I've done here as I've described the embedded arrays with a little plus symbol because I've collapsed them. If I click on that plus symbol and expand it, I can see everything about the plans that are part of that member, the addresses that that member has, any kind of communication preferences. But now I need to deal with the clinical reports and the programs. And so let's say that the new member collection is going to contain arrays from legacy. It's going to contain the plan information. It's going to contain the programs that the member eventually gets enrolled in automatically with our feature. And that member collection is also then going to have a related clinical report fire object. Now, I could probably model that as one collection. I might need to model it as two. If I'm a small healthcare provider and I'm a specialty vendor and I only see patients for very specific procedures and the likelihood of one patient coming to me more than 2 or 3 times is low, I can embed those clinical reports into the member collection. If I'm a healthcare insurer, I probably need to cast that out into its own separate child object because it could be a lot of repeating group information. Over time, a member might have a lot of clinical reports, and that could be a large growth array. So I'm going to push that out and join it when I need to, just like I do with relational. And so the new member collection will then need to be loaded with data designed by the product team, the program collection, sorry. So this is the program collection. So now how do we bridge this gap between the member who has clinical notes between the programs that are correlated to those notes? And we're going to go through this now in our feature architecture. So here, I've actually pulled up a record from the database, and I can see now I've expanded the MongoDB collection on the left to include the clinical notes. And I expand that array, and I see in that array, I see a notes field, and I see a conclusions field, and I can see a conclusions SNOMED. SNOMED is just another type of data standard in healthcare. I can have a couple of different representations of the same data in a couple of different formats, all nicely, elegantly tucked into that array in MongoDB. But the problem here is that is a lot of text. A lot of textual information. I certainly don't want to have people reading through that to make a determination. Based upon your notes, here's the recommendation of the programs that I think you should be enrolled in. How do I automate that? How do I do that programmatically, quickly? All right, so let's take a pause here because it wouldn't be an Agile release without a surprise. And so we were kind of all along assuming that, well, we're just going to push all that note data into the analytics space. I'm going to push it into the data lake. The data scientists will just run machine learning against it, maybe natural language processing, and come up with some auto assignment, right? Great. Product owner says, no, sorry, we forgot to tell you, The program identification and assignment needs to be done in 3 to 5 seconds. Oh, shoot. Well, I only move data into my data lake at night. It's not going to work. Hey, data lake folks, I knock on the data lake folks' door and I say, hey, can you do this in 3 to 5 seconds? No. They tell me, well, do you have 6 months? All right, so we now have a PowerPoint from our business product owner. They're like, here's how the flow is really supposed to work. Okay, the doctor submits the notes, and they're here in the exam room, and they hit submit, and they type up their clinical notes, and they hit submit. And we want that API now to call the insurance company, and we're going to find the valid programs to suggest. The doctor will actually get a list of programs to consider, and the last mile decision will be made by the physician. All right, now I see there's some programs here, health and wellness programs I should consider signing this patient up for. Here's the one I think is probably the most appropriate. And then back to the insurance company. All right, we've got the enrollment. We're going to update the member collection with the actual program code or program ID that I'm going to enroll that member in. Well, this looks good on a PowerPoint, but how do I solve this problem programmatically? So back to our feature wiki, feature architecture. All right, so before we had a MongoDB collection, and we have some clinical notes, and those notes are here on the bottom left. So I'm going to read that note array. I'm going to call an embedding model API, and I'm going to turn those notes into vector embedding. And here's the really great thing about MongoDB. I'm going to store the resulting vectors in the same MongoDB collection. I'm going to add a new array called note vectors, and I'm going to store the arrays for the corresponding notes above in the same MongoDB collection. And the real advantage there now, from a data engineering perspective, is I've got my collection, and I want to now turn those vectors into vector search. You turn your MongoDB collection into a search index. It's actually a vector search index, technically. But you're going to take that database object in MongoDB and create an index from that collection. And the really nice thing here is that when I want to use the search index versus the actual base collection, as a developer, all I have to do is write an aggregation pipeline query that starts with $search, and that will redirect my query to the search index versus the collection. And what's really great is that any edits that I need to make to that data set, I'm just making the edits in the base collection. So now anything that I do in MongoDB, basic CRUD operations to update collections, that's going to be the data object that is then going to be federated into your search index. So what we actually do is we co-locate your search instance, a Lucene index, right next to your MongoDB database on the same node. And we put a change stream listener against the database, so any updates that you make to the collection get federated into the search index automatically. So you as a developer, all you have to do is maintain a collection, and then any edits that you make to that collection then just automatically get hydrated in milliseconds into your search index. So awesome. All right, so this is great. So now I have 3 database objects. Again, if I'm a small practice, I could probably do this in 2 collections. 3 collections. Now I've gone from legacy, 12 or so tables. I've brought legacy in. I'm now extending legacy in the MongoDB ODL with a clinical report collection. Now I still have to now connect that program collection though, right? But the really nice thing is I've got 3 database objects. Those 2 of those database objects have corresponding indexes. But again, those indexes, I don't have to do anything separate. I just edit the data in the collection, and the search indexes are all updated automatically for me. So okay, back to our feature architecture. Now, how do we map from clinical notes to recommended programs? Okay, so the doctor submits those notes, and as Francesca explained earlier today, you can take that clinical note data in your API and immediately turn those notes into vectors. So as soon as the doctor submits those notes, turn those notes into vectors, and then bump up against the search index instance using $search of the program collection. So here's all my clinical programs that my data scientists and product folks have created. I want to match that one instance of note data to any hits I get in the program search index. And so I write a $search query. I pass in some vectors. Let's say that I get 2,000 results. Shoot, this is not going to work. I can't put 2,000 results back in front of the physician, right? I want to further refine that result set and whittle it down. So the great thing about using the MongoDB aggregation pipeline here is that after your $search stage, you can do some filtering inside the search stage, but after your $search stage, you can chain on as many other additional MongoDB aggregation pipeline stages as you need. So I'm going to say, you know what, I found 2,000 results, but you know what, not all 2,000 programs that have been defined in the program collection here in the search index are applicable to this patient. I know that this patient has a specific plan ID, and I know that they live in the state of Massachusetts, so I'm going to now put a match stage at the end and say, well, of those 2,000 results after the search stage, only match on the results that have this plan ID in the metadata and this state code in the metadata. So now I get a further whittled down result set of maybe 4 or 5 plans. Right? So I'm just using basic MongoDB aggregation pipeline queries. I'm doing data authoring in MongoDB collections, and I'm solving for a really complicated scenario here. I've brought legacy in, I've brought the new data in, I've got 3 MongoDB collections, and I'm just writing basic queries here to solve this feature request. So now I want to talk about the deployment architecture. So we've talked about the database objects, what those might look like for this feature. Let's talk about how those features, how those database objects actually get deployed inside MongoDB. So I've got my transactional MongoDB collection. I've got my transactional MongoDB Atlas cluster. That's going to support my APIs. That's going to support also my change data capture from my legacy systems. So any legacy systems that contain member information, maybe I have multiple systems that have members in them. I want to federate all that into a single view in MongoDB. I can then serve APIs up against that single view. I can do a couple of other things though. Inside MongoDB Atlas, we have a bit of an unfair advantage. We can actually spin up additional nodes in your cluster and then right-size those nodes to the particular workload that those nodes are going to execute. So I can say, you know what, I've got my transactional APIs, but I got these big analytic reads that come in every night from the data science folks that comb through the information. They run some really complicated queries. Some of those queries need a lot of RAM to serve up. So I'm going to use asymmetric nodes in Atlas and say that, well, the APIs, those guys run all day on an M30 Atlas cluster, but these analytic nodes need a little bit more RAM. So I'm going to create a node specifically for analytics that has a little bit more CPU and RAM than the transactional cluster does. So rather than paying for the biggest tier for everybody, I only put a higher tier for analytics versus making everybody pay the cost. I can do the same thing for my search nodes. So for your Atlas search nodes and your Atlas vector search nodes, you can deploy right-sized nodes in your cluster to support the search. So my APIs might have a lower workload and lower RAM requirement than the vector search does. And if I can deploy those on 2 different servers with 2 different specs, I can really right-size my cloud cost here. And then a couple of different ways that I want to get the data into, obviously, enterprise analytics. So we've just kind of talked about transactional and, in my opinion, like in-app or real-time analytics or whatever you prefer to call that. Let's talk about enterprise analytics. I can use that same architecture now to connect to the lakehouse or data warehouse or data lake. I can use Kafka streaming here. I can connect to MongoDB via Apache Spark. I can connect up to MongoDB with our Atlas SQL client. So if you've got like Power BI and Tableau users who want to come in and just grab all that data every night and build a universe of reporting objects and reports, you can do that through our Atlas SQL client. You can actually use our data lake functionality to archive data out. So I've got a deep history in archive in S3, still queryable through MongoDB, but I don't need to pay to keep 10 years of history on my online cluster. So again, kind of really right-sizing that deployment. So I want to now talk about MongoDB for enterprise deployments. Let me go one page back here. Oh, sorry. Yeah, MongoDB for enterprise deployments. So now, all right, the Agile delivery team is convinced this is awesome. I've got 3 MongoDB objects. I can deploy those objects really efficiently and really elegantly on MongoDB Atlas. We got to sell this to the enterprise now. The enterprise architects are like, we really like relational SQL. But just like the Sons of Liberty, we know that we are change agents. We are insurgents to make it easier and better to work with data. So we're going to bring a pretty compelling argument here, right? Well, taxation without representation here. You know, we're getting taxed by the crown and we don't have a seat in parliament here. So what is our argument here for the enterprise folks? Well, I'm going to steal a little bit of some of the domain-driven design principles here, because it's easier to argue about domain-driven design than it is to argue about database technology and the document model versus relational. I know that domain-driven design says break up the complex into more manageable, smaller pieces. Great, I like that. We call that the bounded context. Draw a circle around it and call that the member domain. Draw a circle around it, call that the product domain. And then I can align most of my enterprise, and I can do this at the Agile program level, where I'm only doing it with 5 Agile delivery teams, and we build this little enterprise domain kind of concept. Or I can do it at the actual full enterprise level, where I say my entire organization is now going to embrace these concepts. But here's the really important part. Inside the domains of these bounded contexts, each domain really contains a few things. It contains the domain model, and that domain model is the representation of the legacy systems that are inside that domain. What did that legacy member domain model look like? How does it manifest itself now in MongoDB? What are the APIs and events that come off that member domain? What are the AI and in-app analytics functionality that I now need to add inside that domain? And how does that information supply or interact with enterprise analytics? Because the enterprise analytics folks are going to want to know, if you go off and you carve off a little piece of our operating systems, our business systems, and call that a domain team, how do I get the data out for enterprise analytics? I care about more than just member. I care about the whole thing, right? Well, I think we go back to some of this concept of data mesh, and we say that really cloud modernization is really a fabric of domain-based APIs and events. And so what I want to build on the left is that feature that we just walked through for how do I supply information for member processing. How do I build an application that can call on multiple domains now of right-sized deployments, of elegant database objects? Each one of these domains now has enveloped the complexity of legacy and moved into maybe 1 or 2 cleaner MongoDB collections. Because most of these domain teams are going to actually probably use 1 to 2 to 3 MongoDB collections. And in the time that I spent at Travelers, that was probably the most beautiful thing that I got to see, is that as you break up your enterprise into domains, each one of these domain teams using MongoDB uses only a handful of database objects, like 1 to 2 MongoDB collections. And when I do that, I'm going to go back to that deployment diagram and can talk to leadership and say, well, this is my domain model here now. How we just architected for that little feature is actually how we want to break up and reorganize and re-architect at the enterprise level. Because I can take that one little feature, that one little spark of change, and build something that can turn into a bit of a revolution inside your own organizations. I can just wrap a boundary around that and call it the domain and say, this is how I want to architect going forward, because I think we know a better way to work with data, a way to fold legacy complexity in, and a way to serve still the enterprise concerns of enterprise analytics. And here's where I think a couple last points I want to make, and then we're going to move on to the panel. Some people prefer not to talk about MongoDB. Some people prefer not to talk about the document model versus relational. Okay, well, domain-driven design says, again, just like the bounded context, we draw a boundary around it to try to manage the complex into more manageable pieces. Aggregates in domain-driven design do the same thing for your data. We treat like data as a cluster of related things, as a single unit of change, as a single object. And you can see here, so I've got this insurance policy. That policy might have a few addresses, a couple of insured items. But these are really fundamentally the same thing. It's the policy. But in relational, repeating groups get cast out into child objects, and you end up with dozens, hundreds, thousands of tables. Well, domain-driven design says you treat all those as the same object, because fundamentally, programmatically, it's really the same thing. So here's a way to talk to your leadership about the document model without mentioning the document model. And the best thing about those aggregates, especially if they're in MongoDB, is let's say we build that one member collection. Well, I can build a lot of APIs against that one database object. Feature delivery for the next 2 to 3 years can probably be done against that same one MongoDB member collection. Yeah, that member collection might expand over time. I might need to add a lot more fields as more features get added. But an agile delivery team, and the ones that I supported and saw in Travelers, would build 1 to 2 MongoDB collections, and 3, 4 years later, they're still dealing with that one database object. So you build all these APIs against that one database object, and then you can fire off and serve events from that one MongoDB database object, just like you do with APIs. So it's really a thing of beauty to see so much workload, so many different APIs that can be built against one database object. And lastly, before we wrap up, putting this into practice inside your own organizations is sort of like climbing a mountain. And there's this mountain climbing analogy of, well, we establish base camp and then we go for the first summit. And we don't ever really know where the top of the mountain is. We just know that we just keep climbing to the next summit. And once we get to that summit, we try to traverse to the next one. And so my advice for climbing the Agile mountain and refactoring enterprise is to start with Basecamp. And Basecamp, it's about the business feature. It's about the catalyst of change that can create the spark of revolution inside the organization. Align your domain delivery teams, or align your delivery teams to a domain, and then take some provisions. Do I have the technology lined up? Do I know what database I want to use? Do I know what programming language I'm going to use? Do I have access to the source business data? Have I created my feature wikis and given my delivery teams instructions so they build in the direction that I want them to? And then when I execute, what that really looks like is I've delivered some working code, some semblance of working code to the business product owner. I've got my core database object. Again, if it's member, I've just built the member domain for the entire organization. Yeah, it needs to be attributed out, of course, throughout the course of maybe 3 or 4 more Agile releases, but I've just started. I planted the seed, I put the flag in the ground, and I'm ready to modernize. And then when I'm doing that, I'm also preparing for the next summit, the next Agile iteration. What other features does that product owner want against that one database object that I can start getting them thinking about right now while we're delivering feature 1 and release 1? Scaling AI, back to the AI point, we're all in this kind of large conversation globally about what AI can do for us. Truly, it's about exploiting data and technology to solve business problems, making our lives better, reducing operational expenses. And what that really means is it's obviously doing more in less time, right? Not having to read through the notes ourselves, having a program that can do that, relying on vectors. And that, in my opinion, if you want to reduce the time to go from business apps to production delivery, it's all about working more quickly with more complicated data. And that is what I think MongoDB and aggregates and the document model does for Agile delivery teams. I'll leave you with this one last thing. I love this quote from Emmanuel Yananzada. The main thing causing organizations to be insight poor isn't a lack of available data. It's about the structure in which the incoming data is being captured, made available, then utilized by that organization. So lots of database objects in relational, one collection that represents an entire domain of APIs. Relational Migrator is a free download. There's the QR code for that. It's the catalyst. It's the fast path to domain aggregates. Again, you can load a collection up and get your development team started right away. This is a wonderful book written by Daniel Kupal from MongoDB, Pascal Desmarais, who's the owner and founder of Hackalade, the data modeling tool, and Steve Hoberman. We've got a bit of an insurance demo. You can download that guy. That's all. Please rate the session. I hope you enjoyed this time. Remember, taxation without representation. The revolution starts with the data. Thank you, folks.